Suppose alpha plus beta equals to gamma. We need to show that the following conditional trig identity holds. Okay, let us begin our proof. So we'll start from the left hand side. On the left hand side, we have cosine squared alpha added to cosine squared beta added to cosine squared gamma. So first what we'll do, we're going to keep the first term as it is, but we are going to change the second term to 1 minus sine squared beta added to the third term that also stays intact. So here we have used the fact that cosine squared beta added to sine squared beta, that's equals to 1. So that's an identity. Now in the next step what we'll do, we're going to combine cosine squared alpha with negative sine squared beta. Right, this is going to be one single term because there's a standard formula added to cosine squared gamma plus 1. Okay, now cosine squared alpha minus sine squared beta, that comes out to be cosine of alpha plus beta multiplied to cosine of alpha minus beta. And then we have the rest of the terms, cosine squared gamma plus 1. So here we have used the fact that cosine squared alpha minus sine squared alpha beta, that's equals to cosine of alpha plus beta multiplied to cosine of alpha minus beta. Fine. Now cosine of alpha plus beta, we can make a change here. So here it's given that alpha plus beta equals to gamma. So since alpha plus beta equals to gamma, we can take the cosine on both sides to get cosine of alpha plus beta equals to cosine of gamma. So we can replace cosine of alpha plus beta with cosine of gamma. So we get cosine of gamma multiplied to cosine of alpha minus beta added to cosine squared gamma plus 1. Next, what we can do, we can consider the first and the second term, and from each of the two terms we are going to take cosine gamma as the common factor, such that we are left with cosine of alpha minus beta added to cosine of gamma, and then we have 1. This is going to be equals to cosine of gamma multiplied to cosine of alpha minus beta added to, we have cosine gamma here. So cosine gamma, as we have already established, that this is also the same as cosine of alpha plus beta, and we have plus 1. Okay, now what we'll do, we're going to combine the two cosine function within the parentheses. We have a standard formula for that. We're going to get 2 times cosine of alpha minus beta added to alpha plus beta over 2. That's going to give us alpha. And then we have cosine of alpha minus beta minus of alpha plus beta over 2. That's going to give us negative beta and plus 1. So here we have used the formula. That means whenever we have cosine of some angle C added to cosine of another angle D, that's going to be equals to 2 times the product of cosine C plus D over 2 and cosine of C minus D over 2. Okay, fine. So this is going to be equals to, now we get 2 times cosine of alpha times the cosine of negative beta. This is the same as cosine of beta. That's because cosine is an even function. And then we have cosine of gamma added to 1, and this is the right hand side. This is the right hand side, and here we have used the fact that cosine of negative beta, this is the same as cosine of beta. Okay, so we can verify that. So we have 1 plus 2 cosine alpha, cosine beta, and cosine gamma. So thus we have successfully verified that the left hand side, that is going to be equals to the right hand side, hence proved.